All right, you guys, so talking about combustion reactions kind of gets its own little blurb because the other ones, right, there weren't any rules to balancing. You just sort of picked an element and you started and you went through and you eventually your reactions were balanced, which is great. But combustion has some rules that are definitely going to make your life easier when trying to do these problems. So as a reminder, this is what our combustion reactions look like, okay? You've got some sort of fuel happening, right? So, this little CXHY, those little X's and Y's are going to be numbers. And as a reminder, I will provide that for you. So no panic there, right? Then we have oxygen, and then it always creates carbon dioxide and water. So the nice thing about combustion reactions is that you don't have to think about your formulas. You don't have to think about what the products are. There's no that part is easy. Balancing them will be easy, but at first it's just take a beat. So trust me, we'll get you through it. So these are the steps I recommend. Just like any balancing, go ahead and list what you have, right? So carbon, hydrogens, and oxygens. And then I recommend that on the product side, you list oxygen twice, okay? And this is because you've got oxygen in CO2 and oxygen in H2O, and so it's just going to be helpful to kind of keep those oxygens separate in your mind when you're trying to balance those, okay? So that's what you're going to do first, and then you're ready to balance. So the order that you want to balance these things is hydrogen, then carbon, then oxygen, okay? So hydrogen has its own little rules. So we say that you can never put an odd number for water. So if you look at the water, the reaction, if you were to put something like a 3 in front of H2O, that would create 3 oxygens, when you distributed that coefficient. But if you look at the left side, on our reactant side, oxygen is O2. And so there is no way to get 3 oxygens over there, right? You can never have an odd number of oxygens on the reactant side because you're always multiplying by 2. So if you want to use something like a 3 or a 5 or a 7 in front of water, just go ahead and double that coefficient and double your fuel, because then you're good to go and you'll have even numbers, okay? So after you balance your hydrogen, then you balance carbon, and then you're gonna look at your oxygens in carbon dioxide, total that up, boop, and balance oxygen after that. I think it can be really helpful to come up with your own mnemonic device for remembering the order of balancing. So mnemonic devices are things like, please excuse my dear Aunt Sally, right? Parentheses, exponents, multiplication, division, right? Something to help you remember something specific. So I thought it might be fun if you came up with one on your own. If you are not a mnemonic device person, that's fine. But if you wanted to, here's a little space where you can make a mnemonic device to remember to do hydrogen, then carbon, then oxygen. Okay, so let's go through some examples. So here we go. Like I said, you're going to want to list your stuff out. So we've got carbon, hydrogen, oxygen, and then this is where I was saying list your oxygen separate on the product side because it's in those 2 places. It's just going to make your life better. So on the reactant side, I've got 2 carbons, 4 hydrogens, and 2 oxygens. Excuse me. And then on the product side, 1 carbon, 2 oxygens, 2 hydrogens, 1 oxygen, right? We're just using our little subscripts to tell us how many of each atom we have. So I said we want to do hydrogen first. So I have 4 hydrogens on the left, 2 on the right. So I would like to balance it using a 2. That's fine. It's not an odd number. So I put a 2 there. Changes hydrogen to 4, oxygen to 2. Okay. So now my hydrogens are balanced. Great. Then carbon was next. I have 2 carbons on the left, 1 on the right. So I'm going to balance that with a 2. That changes carbon to 2 and oxygen to 4. Okay, so now my hydrogen is good, my carbon is good. I'm left with looking at oxygen. So this is where I'll just do like a little whoop, total up my oxygens. I've got 4 and 2, which gives me a total of 6 oxygens. So now I have 6 oxygens on the right, 2 on the left. Balance it out easily with a 3, good to go. All right, so again, hydrogen, then carbon, then oxygen, no odd numbers with water. Let's do another. So again, I'm going to list out what I have. Carbon, I have 5. I have 12 hydrogens and 2 oxygens. Reminder, I'm just using the little subscripts to tell me how many of each atom I have. I'm also listing my oxygen separately since it's in 2 different places. So then from there, I do hydrogen, then carbon, then oxygen. I have 12 hydrogens on the left. I have 2 on the right, so I'd like to balance it using a 6, right? 6 is fine. It's not a number, so we're going to go ahead and do that. Changes hydrogen to 12, oxygen to 6. Okay, so hydrogen's balanced. Now I'm looking at carbons. Carbons, I have 5 on the left and 1 on the right, so I balance it with a 5. And that's fine. Again, this is the only place with no odd number, ever. It's the only place that matters, okay? So that changed my carbon to 5 and my oxygen to 10. So carbon is balanced, so I'm left looking at my total oxygens, which is 16. Therefore, I need to balance with an 8. Great. Now let's look at one where the odd number thing is going to come in. So 5 carbons, 10 hydrogens, 2 oxygens, 1 carbon, 2 oxygens, 2 hydrogens, 1 oxygen. Okay, so I have 10 hydrogens on the left, 2 on the right. So I want to put a 5. No, no, no. No odd number. So instead, I'm going to put a 10. Okay, so that 10 changes hydrogen to 20 and oxygen to 10. But notice, by making that 20, I need to come back over here and fix that by putting a 2 in front, which changes carbon to 10 and hydrogen to 20. So whenever you need to double the coefficient for water, double your fuel. Just do it right off the bat. Double your coefficient for water, double your fuel. Done. All right, so now hydrogen's done. Okay, so that was where that little extra step comes in. Great, carbon, 10 on the left, 1 on the right, multiply by 10. Changes carbon to 10 and oxygen to 20. No big deal. Then from there, totaling up those oxygens gives me 30 oxygens. So I have 30 oxygens on the right, 2 on the left. I need to multiply by 15. All right, so those were your examples. Now it is your turn. You've got your reminder here, and then you have a few different practice problems to do on your own. So good luck.